Let's start the new topic, power and energy associated with inductor L, capacitor C and resistance R in AC circuit. So first of all I am starting my analysis with the definition of power. Is given by the product of voltage and current passing through the circuit. So P is equal to V into I. And if you more simplify this result, then you will get the relation between the resistance and power in this way. Suppose I am substituting the Ohm's law in equation number 1, then V is equal to IR and the current flowing through the circuit is I am putting as it is. So power P is equal to I square R. And in this way the resistance and power are related, but we want to find out in different way with the associative property of power and the components in AC circuit. Here the voltage and current are changing with time because here alternating current is passing. And hence the power represented from this equation P is equal to VI can be called as instantaneous power for AC circuit. So the value of instantaneous power can be asked in 1 marks MCQ. So you have to write down this equation P is equal to VI, or you have to choose from the given options. And in the actual practical performance, we cannot obtain the value of such instantaneous power. So we have to define some real power. And what do you mean by real power? So real power is nothing but the average power for the entire period of the cycle. So let me give you the diagrammatical representation for this statement. So see, in this way, voltages and currents are changing with time sinusoidally. And here, whenever the voltage or current is flowing in this way, then one cycle has been completed. So the period of this cycle is denoted by this distance or this time interval, and that is denoted by capital T. And first of all, I am expanding my instantaneous power, and then we will reach to the real power. So here the voltage which is passing through in this way, I can write down the equation. The voltage V is of the form of Vm cos omega t, and current I is equal to Im cos omega t minus delta. So with these two equations, I can substitute the value of power P is equal to V into I, that is equal to Vm into Im into cos omega t into cos omega t minus delta. Here you should not forget that delta is the phase difference between voltage and current that depends on the arrangement of components in LCR circuit. But we know that the cos into cos formula, which might you have studied in 11th science math subject, cos omega t into cos omega t minus delta. So this is C into C, that is equal to 1 by 2 cos delta. Why here delta comes? Because alpha minus beta. So here alpha minus beta is omega t minus omega t, that are cancelled out, and this minus sign will change into plus sign. So it is plus delta plus 1 by 2. Now we will do the addition of these two angles, and the addition will comes out to be cos into twice omega t minus delta. And so substituting the result number 3 in equation number 2, so we will get P is equal to Vm Im by 2, and you can see this is the formula of C plus C is equal to 2Cc, and so here T2 was not in the multiplier, so in the right hand side I have divided the terms by number 2, and now the inner part of the bracket is cos delta plus cos into twice omega t minus delta, and that is the equation number 4. And therefore, according to the definition of real power, we only want the average values for the entire cycle. And as we have discussed, in the entire cycle, I can make two partitions. Here you may take voltage and current, but in this case you have to take the time. So, when it comes to this particular point, then only half cycle is completed. So this particular distance is t by 2 only. So this is half cycle period. So this is also half cycle period. But the total time interval is denoted by capital T, which is the full time period for half cycle, and therefore I can write down the equation of power according to the definition of real power. P is equal to Vm Im by 2. Now see, I have to find out the average, and for the average I am using over here the application of integration. So 1 over t integration 0 to t cos delta dt plus, you can also substitute the integration value for this one, plus 1 over t integration 0 to t cos of twice omega t minus delta into dt, and hence this bracket is over. Now we will find out this both integration separately, and then we will substitute the value in the equation of real power. So the integration 0 to t cos of twice omega t minus delta dt is equal to 0, and the value of this integration 0 to t cos delta dt is equal to, now see, this cos delta is 0, sorry, it is constant, so I can take it outside from the integration. So cos delta integration 0 to t dt, and that is equal to cos delta into the bracket the integration is t and the limits are 0 to t. That is equal to upper limit minus lower limit. So cos delta into t minus 0, that is equal to t cos delta. And now I am substituting these values into the equation of real power, and therefore the real power P is equal to Vm Im by 2 into 1 upon t, and the integration values are t cos delta and the other integration is 0, so I don't need to write that particular term. If here you can see these time periods are cancelled out, therefore P is equal to Vm Im by 2 cos delta, and that is the equation number 5 for real power. And you can write down in this way. If you want to find out the root mean square values, then I can provide these two denominator by separating in the form of under root 2, and I will apply separately to Vm and Im. Therefore P is equal to Vm upon under root 2, that is Vrms, into Im upon under root 2, that is Irms, into cos delta. So this is one most important form of using RMS values, and from that I can find out the real power. And here the cos delta which you are watching over here. So in the first equation the power was V into I, and here the cos delta is coming into the multiplier. So I can consider this cos delta as a power multiplier, or in particular I can say it is the power factor. And so equation 6 can be written as P is equal to Vrms Irms cos delta. That is equation number 7. So this is the value of real power, and you should define the delta as the phase difference, and with this our power associated with the L, C and R in AC circuit is over. Now we will see some special cases. So why it is necessary to study these special cases? Because in the power factor the phase difference is coming, and this phase difference delta between voltage V and current I depends on the situation of LCR circuit arrangement, or in particular LCR AC circuit arrangement. So here I am writing in this way my first circuit or first arrangement which I am consider over here, that circuit with only resistor. And in this way, or in this particular arrangement, the phase difference was 0. So delta is equal to 0, and hence cos 0 is equal to 1. So the real power is equal to Vrms into Irms. Now I am taking the second situation or second arrangement, you can say, that AC circuit with only inductor. Means only with the value of L. And here The value of phase difference is pi by 2, and we know when there is delta is equal to pi by 2, cos delta means cos pi by 2 is 0, and therefore the power is 0. And so it can be asked, in which circuit arrangement the power is not generating in the circuit. So this is the circuit of the kind which only inductor L. And here, when the current in the inductor increasing, the energy which is coming from the voltage source is stored in the form of magnetic field. Which is associated with inductor, and when the current decreases, then this energy is given back to the source. And hence over here, if you can see, the energy which was stored and the same amount of energy is given back to the source, and hence there is no generation of power, and due to this particular reason the power is coming zero practically, and theoretically we have just proved it. Now let's start the third type of arrangement, that is the circuit with capacitor only. What happens in the circuit which is only with capacitor? So first of all, the phase difference which is arising in the AC circuit, that is delta is equal to minus pi by 2. So over here cos delta means cos minus pi by 2 is also 0. And hence over here the power dissipated or the power generated in the AC circuit is 0. And here the practical reason is given in this way. The charge which is accommodated on the plates of capacitor C, then the energy which is coming from the source, means voltage source, is stored in the form of electric field E, which is produced between two plates of capacitor, and when this capacitor discharge, this is actually the charging of capacitor, and this is the discharging process of capacitor, and at this particular event the energy will be given back to the voltage source. And here also the value of power is again 0. Now the fourth situation, that is for LCR AC circuit. So in this particular case, the value of delta is very well known, but we directly know the value of cos delta, that is equal to R over under root of R square plus omega L minus 1 over omega c whole square. And here the value of cos delta, that is equal to r upon mod z. Therefore, cos delta is equal to r, means the resistance upon impedance. So, from substituting this value of cos delta, so our equation for the power, therefore P is equal to Vrms Irms into R divided by mod Z. So, this is the result number 1, which is very important for the circuit, that is containing all the components. But here you should remember that here the power will be much lesser, because this is the actual power which we have got in the form of circuit with only resistor, and here it is divided by the impedance value mod Z, and so due to this reason the power value in this equation will be less. So with inductor or only capacitor in the AC circuit, the power was 0, and in the LCR AC circuit arrangement, the power or the current flowing in this circuit, means in this particular circuit, the current is called wattless current, because here the value of power is getting less, and so the word used over here, wattless current. The watt used for the unit of power, less means less power, and current stands for representation of I. So with this, our article number 2.10 is over. Now we will solve one important illustration, that is illustration number 14.